So let's do some examples of that. So if I want to know what I to the 17th is, then I'm just going to take 17 and divide by 4. Now, it'll go in 4 times with a remainder of 1. Now again, I don't care that it goes in 4 times. I care that it's remainder 1. Because what that tells me is that it's the same thing as I to the first, which is just I. Let's look at why that's the case. I to the 17th would be I to the 4th raised to the 4th times I to the 1st, because that's 16 plus 1. But if I to the 4th is just 1, 1 time to any power is just 1. I don't care what's going on over there. All I care about is the remainder, how much is left. So how about I to the 20th? How many times does 4 go into 20? It goes in 5 times, but most importantly, what's the remainder? It's nothing. So the remainder of 0 says this is the same thing as I to the 0, and anything to the 0 power is 1. Why is that the case? Because I to the 20th would be I to the 4th raised to the 5th, with nothing else after it. And that's just 1 to the 5th, or just 1. We could go as high as I to the 42nd. We can go higher than that for that matter. But the process stays the same. We say, how many times does 4 go into it? Well, it goes in 10 times, and the remainder is 2. With a remainder of 2, that tells me I'm equivalent to I squared. I squared is equivalent to negative 1. And again, the reason this works, I to the 42nd would be the same thing as I to the 4th raised to the 10th times I squared. That'd give me 40 plus 2. I to the 4th is 1. 1 to the 10th is 1. So all that I'm left with is the I squared, which is negative 1.